In exercise 2, we should find all possible graphs with 3 vertices v1, v2 and v3 and count edges in each graph. Also, we have to find degree sequence of each graph. As you see, I write all possible variants of edges as sets. Note that in set number 1 has an empty value because it does not have any edges. Then I draw all possible graphs, as you see. After that, I found all degree sequences of each graph is like 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 2, and 2, 2, 2. If this question makes sense for pseudographs, the answer becomes infinitive, because we can add any number of loops and parallels edges. In exercise 4, we should count vertices and edges in pseudograph, find degree sequence and verify proposition about some of the degrees of the vertices. As you see, the count of vertices are 6 and count of edges are 12. Degree sequence is equals to 2, 3, 4, 4, 5, 6. If we have Euler theorem, that means that sum of the degrees of the vertices of a pseudograph is an even number and equals to twice the number of edges. Sum will be right if and only if it's an even number. It can be if sum of degrees quantities equals to even number. In exercise 7, we just need to draw these graphs. This designation like K7 or K2 and 3 means bipartite graph. This is a graph which we can split into two sets. All vertices in one set will connect with vertices in second set. If every vertex in first set connects with all vertices in second set, it's called complete bipartite graph. The designation of K7 or with just one number means we have set with 7 vertices and every element connects with each other. Designation of K 2 and 3 or with two numbers means we have two sets with 2 and 3 elements and every vertex in the first set connects with every vertex in second set. I draw graphs K7 quite bad, but you can see that I connect all vertices with each other. In exercise 16, we should make a subgraph of these graphs. Subgraph means a graph that contains all vertices and edges in the main graph. In other case, we just need to draw a graph without some edges or vertices. In exercise 20, we need to find how many edges does we have by using degrees. So by Euler formula, we just need to sum all degrees and divide by 2. In exercise 21, we need to find if graph bipartite or not. Graph will not be bipartite if vertices in the first set connect with each other, or if second set connect with each other. Mostly graphs are not bipartite because it contains triangle cycle with odd vertices. In exercise 25, we need to count how many bipartite graphs have n vertices. Number of n vertices equal to sum of vertices of two sets A and B. I create a small table to denote how many bipartite graphs have with small numbers of vertices, and we can denote that it equals to n divided by 2, but we always take integer number for odd number of n vertices. Also, we can denote that combination of sums a and b is also equivalent to a n divided by 2, which can also prove that this formula is right. In exercise 26, we have a set of vertices v with elements 1, 2, 3 to n. In task A, we should find how many graphs are there with vertex set v. Every pair of vertices can have an edge or not, so the total number of possible edges is n choose 2. This combination formula that denotes like n factorial divide 2 factorial and multiply to 1 n minus 2 factorial. Also, edge can be included or not, which means the answer is 2 degrees 2, choose 2. In task B, we need to find count graphs in that contain triangle 1, 2, 3. So we should include 3 vertices, 1, 2, 2, 3, 1, 3. That means the answer is 2 degrees and choose 2 minus 3. In task C, we need to find total number of triangle in the graph with vertex set V. Any 3 vertices can form a triangle, and there are n choose 3 possible variants of vertices. The number of graphs that include triangle is the same number like in task B. Then we just need to multiply it, and this is answer for this question. Next exercise 35, we can find that is there exists graph with 30 vertices, 32 edges, 3 vertices of degree 1 and 7 vertices of degree 4. Now it's possible because by Euler formula sum of edges have to be 26, but actually sum of degrees equals to 31. It's more than 26 and it's odd number. Next exercise 2, section 3, we should draw isomorphic graphs but without crossover of edges. Next exercise 6, we need to determine is this graph isomorphic or not. I put the labels to the vertices and it's easy to prove that graphs are isomorphic. Next exercise 7, we should explain why any graph is isomorphic to a subgraph of some complete graph. Any graph is isomorphic to a subgraph of a complete graph because complete graph Kn contains all possible edges between n vertices. If we take Kn and remove from its edges that are not present in our graph, we obtain a subgraph isomorphic to the original graph. Next exercise 8, we have two graphs, and in task A, we should prove that two graphs that are isomorphic must contain the same number of triangles. If two graphs G1 and G2 are isomorphic, it means they have the same structure. Every vertex in G1 matches and the vertex in G2, and the connection stays the same. So three vertices form a triangle in G1. The same three matched vertices form a triangle in G2. It means isomorphic graphs have the same number of triangles. In task B, we should prove that for any n more than or equal to 4, two isomorphic graphs must contain the same number of n cycles. The same idea for any cycle with n more or equals to 4. If G1 has a cycle with the n vertices, then G2 also has a cycle with the same n vertices connected in the same way. In task C, we should count edges are there in G1 and G2, and the vertices, and what is the degree sequences of each graphs, and is this graph are the graphs isomorphic. Each graph has 6 vertices and 9 edges. Degree of each vertex equals to 3. Degree sequence is R 3 3 3 3 3 3. The graphs are not isomorphic because G2 has a triangle 1 4 5, but G1 does not. Exercise 9, we have 3 graphs, and in task A, we should count how many vertices, edges, degree sequences, and the triangles in each graph. So in each graph we have 7 vertices, 14 edges. In G1 we have a degree sequences of 7, 4, and in G2 and G3 we have a degree sequence of 5, 4, 4, 4, 4, 4, and 3. In G1 we have 7 triangles, and in G2 and G3 we have 8 triangles. So in the task B, we should identify is this graph isomorphic or not. G1 is not isomorphic to G2 and G3 because it has different degree sequence. G2 cannot be isomorphic to G3 because G2 contains 9 4 cycles, while G3 has only 8. Next exercise 10, we should show these following graphs are not isomorphic. These graphs are not isomorphic because graph on the left has 2 quadrilaterals ABHG and CDFE, while the other has 3 quadrilaterals 1 through 8 7, 3 4 6 5, 1 3 5 7.